the first thing that I want to make clear is just going to be used as a reference. If you have a chord, and again, a chord has endpoints that lie on the circle itself. If you're looking to identify the distance from a chord to the center of the circle, and the distance from a chord to the center of the circle is a perpendicular distance, okay, from that center to the chord. As far as this distance is concerned, there's several relationships that you need to be aware of regarding a chord and its distance from the center. And they're both, or one of them is pretty self-explanatory. If you look at these two distances here, assuming this is the center, what do you notice about the chord that's closer to the center of the circle compared to the chord that's further from the center of the circle? Is it longer or is it shorter? The closer you are to the center, closer to the center, well, the distance is shorter. And so when the distance is shorter, the chord itself is longer. So the relationships that exist are longer chords are closer to the center. And at the same time, you could say the shorter chords are further from the center. And now, at the same time, the other relationships involving this are just other ways to state this same relationship, and that is the closer a chord is to the center, the longer the chord; the further the chord is from the center, the shorter the chord. Okay, so be aware of those relationships. Hey, there's one other relationship that exists when you're looking at chords and their distance from the center, and that is when this perpendicular distance from the center intersects with the chord, it intersects at its midpoint. And so what that means is the perpendicular from the center to a chord bisects the chord. Okay? Or in other words, it's a perpendicular bisector. Okay? So when you draw in this distance, or this perpendicular that marks the distance from the chord to the center, it's going to bisect that chord. And the reason for this is if we were to connect the center to each endpoint of our chord, what we create here, because the radii of a circle are equal, is we create this isosceles triangle. And when you take an isosceles triangle and construct or draw a perpendicular from its vertex to its base, the vertex is the point where the two equal sides intersect, the base is the segment connecting the two equal sides. It will be a perpendicular bisector of that base. Okay, so again, when you're looking at this, the perpendicular from the center to a chord will bisect the chord. The other way to think of this, again, kind of flipping the if-thens, or the conditions on this, and that is if you have a perpendicular bisector of any chord, where do you think that bisector is going to pass? Through the center. So if you take any chord, wherever it might be located, and you draw in the perpendicular bisector, so if you find its midpoint and then a perpendicular through that, it will pass through the center of that circle. All right, so if I were to take a problem and let's say I give these intersections A, B, C, and then D, E, and F points. If I told you, given this figure right here, if AC is 22 and EF is 5, then how does AB relate to df. What inequality symbol would go here? Well, if AC is 22, what does that mean AB is equal to? This perpendicular is going to bisect our segment, so this will be 11. So we're comparing 11 to, and DF, if FE was 5, once again this perpendicular is going to bisect that. What's the total length FD then? And so the inequality symbol would be a greater than. Okay, so be prepared to find the relational symbols to identify specific measures, and it might either be the segments, the chords themselves, or even the distance between or from the chord to the center. And so be aware of working between those different relationships.